Okay, this is number 8 in section 1.4, and the differential equation is dy dx equals 2x times secant of y. And I'm going to go ahead and put parentheses just around my y so I don't separate them. Okay, so here the directions say find general solutions, implicit if necessary, explicit if convenient, of this given differential equation, and then of course primes denote derivatives with respect to x. Okay, so in this section we want to solve these differential equations using separation of variables. So note in the introduction of the section, there's a function that they call capital H of x and y. So this is our x and y in this case because it's a product, right? We're multiplying our function of x and function of y, right? So it's a multivariable expression. Opposed to 1.1, we only had one variable. This was our f of x. So maybe let's point that out. So in 1.2, we had just an f of x, right? And another thing that, well, okay, let's just go step by step. So the goal here, or what we want, is we want to separate the variables x and y, right? It doesn't always have to be x and y, but in general it usually is. Or in other words, we want to isolate, oh, can't write today. Okay, isolate each variable, right, on opposite sides of the equation, opposite sides of our differential equation. Okay, so that's the goal. And the reason why we want to do this is because in section 1.2 we know how to integrate a variable and a function in terms of one variable. So if we separate the variables, then we can integrate with respect to x, and for example on the left, and integrate with respect to y on the right hand side. So that's the reason why we want to do this. Again, we're building upon our knowledge on what we know. Okay, so let's start the problem, and let's move this a little bit. Okay, so we have okay, so I'm going to write the problem again. dy dx equals 2x, and I'll just go ahead and put a dot here, times secant of y. So this is just a proportion, right? Since it is, right, I can cross multiply, right, just by our algebra properties. And so dy times 1 is dy, right, and dx times this expression, right? These are our means and extremes. So we have dy equals 2x times secant of y times dx. And again, I would encourage you to write, well, especially on this side, your dx is at the very end, right? Because when you integrate a function, it's going to be with respect to that variable, and usually we write that at the end, right? The integral of, f of x dx, right? We don't write the integral of dx f of x. I mean, it's not wrong, but this is what's standard, so just to be consistent. Okay, so let's let's move this up. So I want, notice that, okay, the left-hand side is the variable y, and the right-hand side is the variables x, right, and a function of y, and then of course dx. So I want to move the secant of y to this side because it's with respect to dy. So I'm going to go ahead and divide both sides by secant of y, right? Okay, so divide by, right, secant of y, right, or in other words, you're multiplying by 1 over secant of y. Okay, so we obtain, if I rewrite this, we get 1 over secant of y dy equals, and this is nice because we get a big 1, and we're just left with 2x dx. So I've officially separated my variables because I have y, right, a function of y on this side and a function of x on this side. So y's with y's, x's with x's. And before we start integrating, I'm going to go ahead and rewrite secant of y in terms of cosine, because there's a trig identity that says, right, secant of y, right, this guy, that's the same thing as 1 over cosine of y, right, the reciprocal function with respect to dy. And then, okay, we'll just, again, go step by step. So if we simplify this expression, right, using algebra, right, this is just 1 divided by this fraction, which really means 1 times the reciprocal of this. So that's really just 1 times cosine of y. So we have cosine of y dy equals 2x dx. Okay, so now I want to integrate. So, whoops, I want to write in purple. Integral. So what is the integral of cosine of y? Well, remember that the derivative of sine is cosine. So if you want to write, recall. So the derivative, right, for example, of sine of y is cosine of y. And I'm talking about derivatives because the integral is really just the antiderivative. So now I can say the integral of cosine of y is just the sine of y, right? They're inverse functions. So this is what I want, and I'll just continue this. So the integral is sine of y, right, plus a constant of integration equals, and then I can factor out that 2. Again, I'm just going step by step. If you want to skip some of my steps, that's fine, as long as you understand what's going on. So let's see. So we have, okay, sine of y plus c1, and I take the constant multiple rule, and then I can write x squared over 2, right, if I integrate this guy, plus a constant of integration, which I'll just call c2. And this is nice, that's a big 1, so we get sine of y plus c1 equals x squared plus c2. The goal is to solve for y, so I'm going to leave sine of y on the left hand side, and I'm going to just go ahead and subtract c1 from both sides. And here, if you want, you can just call that c, right? Let c equals c2 c1. So sine of y equals x squared plus your constant of integration. So we want to solve for y, hopefully explicitly. If not, it'll be implicit. This one will be explicit. So we have we want to solve for y, but I have sine of y. So in order to isolate this y, right, what's the inverse of sine? Well, the inverse is sine inverse. So sine inverse of this guy and sine inverse of this guy. So that's gone. So we get y, right? Or if you want to write y of x to be more explicit, no pun intended there. Sine inverse of x squared plus c. And so we have solved for y of x, right? This is our general solution to this differential equation. And so this guy is an explicit solution, right? We know it's a general solution because we have an arbitrary constant. Is an explicit solution to the differential equation to the differential equation. dy dx is equal to 2x times secant of y, right? So it's an explicit solution, meaning I can solve for y in terms of x, where when I input a value, I'm only going to get one output for y of x. So y of, some x naught, for example, is going to give me sine inverse of, and then I would input our x naught. So if I know what c is, right, this is an actual curve on your calculator, right? So the sine inverse, right, the curves, something like that. But again, general solutions. So that is it for number 8.